Okay, first you have to go through your atomic structure, basic atomic structure, and then after that you go into periodic table as in group and period. Right, 1, 2, 3, 4, 5, 6, 7, 8. Right, and then you have to know group 1, group 7, period 3, properties of transition, and the properties and usage of your of your group 8. Okay, and then after that, individual properties of aluminium, and then individual properties of just a few of it. Okay, and then after that, once you understand periodic table, then only bonding start to make sense, then only your reactivity series and everything start to make sense. Okay, and then okay, let's start with your atomic structure. So tell me, if I ask you to describe an atom, Balkis, describe an atom. Describe an atom. Okay, Nina, describe an atom.
Atom is the smallest unit. Teacher start saja ke?
Describe an atom.
Um,
An atom is made up of nucleus
nucleus.
containing what?
Containing a nucleon made up of protons and neutrons.
Yes, okay. Made up of
Proton and neutron.
proton, and then what do you know about proton? It's
Positively
charge.
Positive charge.
Right. And then you have the neutron. Right. Neutron has no charge and 1 unit. Yes. Together, this proton and neutron make up your nucleon. Right. And then you have what?
Electron
Yes, you have
in
the
their orbitals.
electrons, right? Okay, the electron is negatively charged and it's 1/1840 unit mass, and this electron is in the orbital, right? Okay, so when they ask you describe an atom or describe an atom of sodium, so you should know. Okay, you have a proton and neutron in the nucleus, and these make up your nucleon. And any element and all the element, remember when you talk about element, what is an element?
The
Simplest
unit
that cannot be broken down for.
that cannot be further. Yeah. Further.
Okay, so every element, all the element that you see in your periodic table can be represented by a symbol, right? So say you have sodium 2311. So when you see this, the smaller number is your proton number. And 23 is your nucleon number. Remember? Or at times they ask the proton number is your atomic number, nucleon number is the mass number. At times they say this is your atomic number, this is your mass number. Okay, now, so nucleon number means that this is proton and neutron. So if I give you 2311 sodium, means how many proton?
11.
11. How many neutron?
12.
12. How many electron?
11.
11.
How do you know electron is 11?
Because it is the sodium is no charge, has no charge.
Balkis, why is 11? Why electron is 11?
Because proton is equal to electron.
Kenapa proton has to be equals to electron? Remember, they do ask you, right? If you have done the passive paper, they do ask you. Most of the time, I mean, not most of the time, they will ask you several times. So why? How do you know electron is 11? Because for a neutral air atom, number of proton equals to number of electron, because proton is positively charged, electron is negatively charged. So for a neutral atom, number of proton equals to number of electrons, right? Okay. Now next, what happened? This electron is being, or if I give you chlorine 3517, so proton equals to 17, neutron equals to 18, electron equals to 17, right? So this electron is arranged in orbitals. So remember, innermost orbital can occupy?
Oh.
Can occupy?
Or in a 2.
2. Right, so if I give you sodium, and then maximum, the rest is 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 plus 8 and 1. Right, so 2, 8, 1. This is the electron configuration for sodium. 2, 8, 1. Right. And then if I say chlorine is 17, so 2, 8, 7. Right. Okay. Now, so this is what you call apa?
Valence.
Valence electron.
Valence electron.
The outermost shell is called valence electron. So now when you see sodium is 281, mean that it has 3 orbitals and then it has 1 valence electron. From here, you can look at your periodic table and you know sodium is in group
Group 1.
1,
Group
Period
1.
3.
period 3.
Period.
How do you know? Because it has 3 orbitals and it has 1 valence electron. So if chlorine, I know is group 7,
Group
7,
7.
period
7.
3.
Period.
Right.
3.
Or if I give you potassium, potassium is 40, 19. So proton is 9,
19.
neutron is
21.
electron is 19. Right.
19.
19 will be arranged as 2, 8, 8, 1. Right. So where is potassium in the periodic table? Group
Group 1.
1.
Good. 4.
Yeah.
Understand? So you can tell the position of the element in the periodic table because element in the periodic table is being arranged according to increasing number of proton. Okay. Now we'll come back to that. So here, from here, you know the position in the periodic table because the periodic table is being arranged. The element in the periodic table is being arranged according to 1, 2, 3, 4, 5, 6, 7, 8. According to increasing number of
Proton.
right, increasing number of protons. So you go across and you keep increasing number of protons. Once you know that, next one is okay. Now, when you have an atom, like you have sodium 281, okay? Remember, when you have your valence electron, right? And why is it you have all this chemical reaction on Earth? You know, like hydrogen react with oxygen, sodium react with oxygen, sodium react with water, sodium react with all those things. It's because all the elements need to stabilize themselves to have an octet stability. Okay, octet or duplet stability. So in this case, sodium is 281. To achieve octet, it will lose 1 electron. You get that? So if I give you sodium 2311, it has proton is 11, electron is 11. Right, so 281. To achieve octet, it need to have 8. So what happens is it get rid of 1 electron. Right, so when you get rid of 1 electron, now you have proton is still 11, but electron now is 10. So more positive or more negative? More positive or more negative? Asna,
More
more negative.
Positive.
More positive. How much more positive?
By 1.
By 1. So therefore, Na positive, right? So, or if I give what else? I give you aluminium, okay? Aluminium 26, 13. So proton is 13, electron is 13, and this electron is 2, 8, 3. Now, Asna, how does aluminium achieve octet stability? Is Asna there? Asna tak ada?
Tak ada teacher.
Okay, tak ada. So, how, Balkis, how does aluminium achieve octet stability?
By losing electrons or
How many
donating.
electrons?
3.
3 electrons. So, minus 2
3
electrons.
electrons.
So, that will give you Al 3 plus. Right. Configuration now is 2,
Yes.
8. So, now from now onwards, you know, if you have an X minus N number of electron, it become Xn plus. Right. Now, what if I have oxygen? Oxygen is 16, 8. So, proton is 8, electron is 8. So, this is 2, 6. How does it achieve octet stability?
Gaining 2.
Gaining 2 electron. So, when it gains 2 electron, proton is still 8, electron now is 10. More positive or more negative?
More negative.
Or
More
negative.
negative.
By 2 negative.
2 negative.
Should be O2 minus. Get it? Or if I give you chlorine, chlorine 35, 17. So proton is 17, electron is 17. 2, 8, 7. How does it achieve octet stability? Wait, how does it achieve octet?
Gain 1 electron.
In 1 electron,
Gain.
right? So now it becomes what? Cl minus, because now it's 2, 8, 8, right? Proton is still 17, electron now is 18, right? So from now onwards, you know, X plus N number of electron will become X and negative, right? You understand this first, and then you understand when we do oxidation, reduction, gaining, losing, and ionic equation and everything. If you cannot understand this, then the rest doesn't make sense to you. Okay, understand? Yes, no? So now, when I say group 1 will have how many valence electron?
1.
1.
1 valence electron. Group
What?
valence
Two.
electron. Group 4, 4, 5, 6, 7, and 8. Right. And except for transition element. Transition element, right. Okay, transition element will show different properties than the rest. Transition element, give me 5 properties of transition element, quick.
Catalyst.
It is catalytic.
Catalytic.
More than one
Forms.
oxidation state.
Yes, it has
Or
more
than
than one oxy.
oxidation state.
Oxidation
Color.
state. It can form colored compounds.
It has high
Highly colored.
melting point and boiling point.
Highly colored compound.
Okay, yang tu Nina, bila when they ask you to compare transition metal with group
Oh,
1,
okay.
you get that?
Uh-uh.
Because they are metal, they show properties of metal. They have high melting and boiling point. But if the question asks you to compare properties of group 1 metal with transition metal. So transition have a much higher melting and boiling point. They are denser and all those things. But this is just exclusively for transition. They are metal, yes, of course, they show all properties of metal.
Metal.
Already learned all the properties of metal, and then they can be catalytic. They have more than one oxidation state. They form colored compound. Remember this morning when you see pink
Manganese.
manganese. So immediately you know it got to be a transition element, right? Okay. When you see green color, you know it got to be transition. Okay. So you do enough, you know the color. But otherwise, you know, whenever colored, it got to be transition, right? It's catalytic, it form a colored compound, it form more than one, and then it can form complex compound. compound. Like later on, you learn about hexacycloferrate and everything. Many complex compound. And then it can also what? Some of them are also
Oh, magnetic, yeah.
right? Like you have copper, you have nickel, copper and nickel, tungsten. They are magnet. Okay, get it? Yes? No?
Yes.
Okay. So remember the 5 properties of transition element. Now next you have to go for your group 7 and period 3. I'll do period 3 first. Those of you yang ingat, recall back. Those of you yang lupa, try to recall back. Okay. Now, when you talk about period 3, you have your sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Right. The sodium is group 1, magnesium group 2, aluminium group 3, silicon group 4, phosphorus, sulfur, chlorine, argon. So sodium group 1, so this is period 3. So how many orbitals? How many,
What?
period 3, how many orbitals?
3.
3
3.
orbitals. So sodium should be 2, 8, 1.
2, 8, 1.
1.
2, 8, 2.
2, 8, 3. 2, 8.
4.
Phosphorus is
4.
8. 5. Sulfur
2, 8, 6.
6. Chlorine is 2, 8, 7.
2, 8, 7.
2, 8, 8.
2, 8,
Right. Okay, now, so physical properties first. When you talk about sodium, magnesium, aluminium, they are what? These are
metals.
metal.
Metal.
So they show properties of metal. What are properties of metal again? Malleable, ductile,
Ductile.
malleable, sonorous,
Conductor.
good conductor of electricity, it can turn into alloy and all those things. Right. And silicon is metalloid. Metalloid means that it shows properties of metal but not as good as metal. It can conduct electricity but not as good as metal. Okay. Remember those of you who have done your kat mana kita jumpa metalloid, non-ohmic conductor, where did you come across it?
Physics.
Which part of physics?
No.
Electronics.
Electronics.
Electronics. Electronics are made up of, electronic components are made up of non-ohmic conductor, the non-metal, right? Then you have phosphorus, sulfur, chlorine, argon, they are
Non-metal.
Non-metal.
non-metal, non-malleable, blah, 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 all those. You have done this in your check point, right? Properties of metal, you know, it's sonorous, gray color, shiny, and all those things, okay? Now, when you talk about your, remember just now I said, why is it that the all element react together to form a compound is because the element need to achieve octet stability. Octet stability means you have to have 8 valence electron, duplet or octet stability, right? So for sodium to have octet stability, it will do what? Marcus, how does sodium achieve octet stability? Marcus, how does sodium achieve octet stability?
Yes.
How does sodium how does sodium achieve octet stability?
By losing 1 electron.
From what? By losing 1, it form what? Okay, just now what did you learn, Marcus? Losing 1 electron, it form +1. Losing 2 electron, it form +2. Losing 3 electron, it form +3. So coming back here, you have 281, sodium. So sodium is 1 electron, so sodium will form +1. Magnesium +2, aluminium +3, silicon 4. Okay, now phosphorus, Atika? Phosphorus have 5, Atika. How does it achieve octet stability?
It gains electron and then
It gains how many electrons, Tika?
3
3 electrons. So what charge will it form?
+5.
It gains 3
Plus. Minus 3.
minus 3. So P minus 3 minus. Right, sulfur, Tika.
Minus 2.
2 minus chlorine.
Minus 1.
Argon?
0.
No. Okay. So if the question says argon is chemically inert, why? They ask you to explain why argon is chemically inert. What's your explanation? What's your explanation? Nina, what's your explanation? The statement is argon is chemically inert. Explain.
It already has it already has achieved Octet stability.
Yes, it has achieved stability with 8 valence electron. Therefore, continue. That is only 1 mark.
Uh,
It will not
Therefore, it will not lose or gain
React.
electron. React.
lose or gain or share electron.
Electron.
What it means chemically inert, because in a chemical reaction, what happened? Electrons is either lost or gained
Or
or
share.
Share.
later on. That will be elaborate further. You see, when you do bonding, electron are being either shared, lose, gain, or being shared, right? So, but with argon, because it has 8 valence electron, argon will not lose, gain, or share electrons. So they are chemically inert. Okay. Now, so in terms of chemical properties, okay, but before that, so sodium has a valency of, what is the valency?
1.
1.
1.
Sodium has a valency of,
Magnesium.
yeah,
2.
has a valency of 2. Aluminium has a valency of,
3.
3.
silicon has a valency of,
4.
4.
phosphorus has a valency of
5.
3.
Oh,
Okay.
3 here.
Because valency, how many single bond can it form with
Ah.
hydrogen or other atoms? Can form 3. So therefore valency of sulfur,
2.
2. Chlorine,
1.
1.
okay. Now the charge, what is the charge for sodium?
And A plus.
Plus 1. Magnesium,
Plus
Plus 2.
plus 2.
Plus 2.
plus
Plus
3.
Plus
3.
3.
Right. Okay. So here, when you talk about the valency, this is valency of 1, 2, 3, 4, 3, 2, and 1. Okay. Now, if the question says from sodium to silicon, the valency increases from 1 to 4. Explain why. So, what's your explanation?
Allah.
Valency of the element from sodium to silicon increases from 1 to 4. Explain. How do you explain that? Tara?
Yeah.
Valency element increases from 1 to 4. From sodium to silicon, it increases from 1 to 4. Why?
Valency of sodium is 1 because it loses 1 electron to achieve octet stability.
So when you talk about valency, you talk about from
Gaining and
sodium. How do you
losing.
explain this, Sarah? It's only 2 marks.
Huh?
From sodium to silicon, number of valence electrons
Oh yeah, from sodium to silicon.
from 1 to 4.
Yeah.
Okay, so number of valence electron increases from 1 to 4.
4.
Get that? Hence the valency of 1 to 4. And the charge increases from plus 1 to plus 4. Now explain why.
The charge increases to plus 1 to plus 4 because it requires, from sodium to silicon, it requires 1 to 4 electrons respectively to to achieve octet stability.
Sodium loses 1 electron.
Yeah.
Okay, to achieve octet, magnesium, aluminium, and silicon loses 2, 3, and 4
2,
respectively.
3, and 4.
From +2, +3, and +4.
4.
Right. Okay. The valency decreases. Valency and charges decreases from silicon to chlorine. Reason?
Valency decreases from 3 to 1 because it from phosphorus to chlorine, it from phosphorus to chlorine, it loses 3, 2, and 1 electrons to achieve octet.
3, 2, and 1, Sarah. Careful.
Oh, it gains 3, 2, and 1 electrons to achieve octet
Talk about
stability.
number of valence electron again. So phosphorus have 5 valence electrons. Sulfur have 6. Chlorine have 7. Hence, valency of 3, 2, and 1. To achieve octet stability, phosphorus gain 3 electrons, sulfur gain 2 electron, and chlorine gain 1 electron. Hence, charge of -3, -2, -1. Okay, you have to be able to explain this. They will ask you, why is it that the valency increase, decrease? Why is it that the charge increase, decrease? Okay, don't lose marks. Okay? It looks mundane, but you have to be good with explaining this. Okay, now, so next one, at times they ask you, what if sodium react with sulfur? What is the charge? What is the formula of the compound? Remember sodium? Na plus, sulfur 2 minus. So what is the formula for sodium sulfite? Ina?
Na2S.
Na2S. They do ask you this. What is the formula for magnesium phosphide?
Mg3P2.
Mg3. Right. So know this. Okay. Okay. Now another one is in terms of oxide. So oxide of sodium, magnesium, and aluminium is what? Sodium and magnesium. So sodium oxide and magnesium oxide are basic, acidic, or neutral? These are
Basic.
What does it mean it's a base?
Oh.
What does it mean it's a base?
It is a proton receiver.
No, that one if you talk in terms of your acid and that. But in this case, I mean it's a base here. What does it mean? It has basic properties, mean that it can neutralize acid to give you salt and water.
Salt and water.
Okay. Now Al2O3, this is what you call?
Amphoteric.
What does it mean? Amphoteric, it has both
Acid and base.
base. Right. Okay, meaning that how do you test for basic oxide? You add what? You add
Acid.
acid. Dissolve. Right. How do you know it's amphoteric? You add
Alkali.
it dissolve. You add acid. It also dissolves. Right. And the oxide of silicon, phosphorus, sulfur, and chlorine all are apa? Acidic. Right.
Acidic.
It dissolve in alkali.
Alkali.
Okay, you have done your redox, you covered all. Give me one reaction in the blast furnace between acid and base. Arif, what's in the blast furnace? That is a reaction between acid and base, Arif. I mean, the reaction between acid and base.
Calcium oxide and silicon oxide.
Again,
Calcium oxide plus silicon oxide.
calcium oxide.
Plus silicon oxide giving calcium silicate.
right? Okay, to form slag because silicon dioxide is acidic, calcium oxide is a base, right? So from here, you have to remember because you carry this, okay? You notice we carry this concept a long way. What concept do you have to remember? Metal oxide is what? Metal oxide is
Acidic.
metal
Acidic.
oxide is a base. Non-metal oxide
Oh, acidic.
is acidic. Right. So remember this. Now, what are non-metal oxide? Acidic non-metal oxide that is harmful to the environment?
Methane.
Huh? What are non-metal oxide that is harmful to the environment?
Sulfur dioxide.
Sulfur dioxide. Right. So you talk about sulfur dioxide. Where do you get sulfur dioxide from? What's malam? Where do you get sulfur dioxide from?
Oxygen.
Where do you get sulfur dioxide from? Sarah, sulfur dioxide from?
Fossil.
Yeah,
Burning of fossil fuels.
burning of fossil fuel, right? Okay, burning of fossil fuel will give you sulfur dioxide, which is acidic. What else? What's another sulfur dioxide? What's another acidic oxide that is harmful to the environment?
Oxides of nitrogen.
Oxide of nitrogen. Where do you get the oxide of nitrogen from, Sarah?
The high heats of the high temperatures of the exhaust causes the nitrogen in the air to react with the oxygen in the
So
air.
you talk about exhaust fumes, right? Okay. Now, which non-metal oxide is neutral? Or another non-metal oxide that is acidic that we talk about what? Carbon dioxide. When you talk about carbon dioxide, you talk about what? Global
warming.
Global warming.
warming. Right. When you talk about oxide, sulfur dioxide and oxide of nitrogen, how does it causes acid rain?
It dissolves.
Dissolved in the water.
Dissolve in water vapor, dissolve in rain to give you acid.
Acid rain.
So what is the effect of acid rain again?
It's corrosive.
Corrode the buildings.
It corrodes building, right? It corrodes building. Why does it corrodes building? Explain. What are building made up of?
Calcium carbonate
Calcium carbonate. So
plus
carbon
acid.
give you salt, carbon dioxide, and more.
Water.
Right, and then it has an effect on the aquatic life, right? Okay, and then it also causes the soil to be
Acidic.
acidic, right? Okay, now so know all those as well. And then remember, metal oxide is a base with a free substitution. Like you have Al2O3, M43. But aluminum oxide is M4. What's the advantage of aluminum oxide as is M43? What is one property of aluminum that is that rely on the fact that on the aluminum oxide? When you talk about aluminum, remember aluminum is a metal, so it's malleable, it's ductile, it conducts electricity, blah blah blah. Now, one property of aluminum that is due to the oxide layer. What is that?
Stable oxide layer.
Yeah, stable oxide layer. So what actually you use it for, Tasnim?
Okay. You can store food.
Yes, you use aluminum to store food as food container because it has a stable oxide layer. Okay. Now, you okay with that? And why is it that aluminum is used as aircraft?
It has a
like
low density.
It has low density, right? It has low density, so you use it for aircraft, right? What else? It has a stable oxide layer. So you use it as what? As
Cans.
canned drinks, and then as food container.
Tupperware.
Food container. Tupperware plastic sayang weh.
Yeah.
Right, what else? It conduct electricity.
Electricity.
So you use it as cables, right? Conduct electricity and it's ductile, right? So therefore you use it as cable. It has low density, so again we use as overhead cables, right? Overhead cables, remember, are actually made up of steel wrapped with aluminum wires. Okay, now, okay with this? Yes, no? Boleh? Which oxide is harmful to health?
Carbon monoxide.
Carbon monoxide.
Carbon monoxide.
What's wrong with carbon monoxide?
Respiratory poison.
Yes, it's a respiratory poison. Okay, so know all this in terms of oxide and all those. Okay, so once you understand this, then you can go into your group 1. So when you talk about your period 3, know sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, and then know that sodium, magnesium, aluminum are metals. So metal, therefore properties of metal, they are malleable, they are ductile, they conduct electricity, they're sonorous, and all those. And then silicon is metalloid, the rest are non-metal. And then what else? And then you talk about the chemical property, talk about the oxidation state, increases from sodium to silicon, decreases from phosphorus to chlorine, and you have to know why. Okay, your justification will be again the number of valence electron. So to achieve octet stability, sodium, magnesium, aluminum, and silicon loses 1, 2, 3, and 4 electron respectively to form +1, +2, +3, and +4 charges, right? Well, phosphorus, sulfur, and chlorine have 5, 6, and 7 valence electron. To achieve octet stability, it gains 3, 2, and 1 to form -3, -2, and -2 respectively. Okay. Now another property is oxide of metal are what? Acid or base? Oxide of metal are acid or base?
Base.
Base.
Oh,
Not
base.
metal are acid.
Acid.
And know how to test for it. If they give you sodium and magnesium oxide, how do you know they are basic? They dissolve in acid. How do you know aluminum oxide is amphoteric? They dissolve sodium hydroxide, they dissolve both in sodium hydroxide and hydrochloric acid. And oxide of silicon, phosphorus, sulfur, and chlorine are acidic. How do you know? They dissolve in sodium hydroxide. Okay, and then know the properties of a few oxide that is concerned with the acid rain, everything, and then know also the properties of aluminum. Okay. Now, once you know that, the next one will be your group 1. Right. When you talk about group 1, so this group 1. What are group 1? You start off with lithium, potassium, rubidium, cesium, francium.
Francium.
So as you go down, remember this is group 1. So how many valence electron, Balkis?
1. 1
One
valence
electron. So this is 2, 1, 2, 1. Right. This is 2, 8, 1. This is 2, 8, 8, 2, 8, 8, 1. Right. You see, as you go down, number of orbitals increases, size of the atom increases. Okay, size of the atom increases. Now, as you go down, physical properties. What happened to the melting point and boiling point? Increase or decrease? Increase or decrease?
Decreases.
It's not here yet. You see? It's not here. Tak ada.
No.
Okay. Going from lithium, sodium, potassium, rubidium, cesium, francium. Increase or decrease?
Decrease.
Huh?
Decrease.
Decrease. Why decrease? Why decrease?
Positive metal ion are further away from the electron as it goes down the group.
Again, enough? Because?
Positive metal ion are further away from the electron as it goes down the group.
You show positive metal ion.
Uh,
Okay, now lithium, sodium, potassium, rubidium, cesium, francium. These are metal. So metal have metallic bond. So metallic bond is, you have to know metallic lattice. So all of you know metallic lattice already, right? So describe metallic lattice. That's name?
The
Layers of
positive
Metal ion in the sea of
ion. Yes, you have to last like
okay, layers of positive metal ion is sea of delocalized electrons. So here you have your positive metal ion. And remember the valence electron in metal, the valence electron is not fixed. Okay. Okay, and the valence electron is actually delocalized, means that it's not fixed, it's everywhere. It's like you have a box and then you have your football, you arrange the football in the box, and then after that you pour the ping pong ball and you shake. So the ping pong ball is the valence electron and the football is the positive metal ion, right? So this is metallic lattice. So we will discuss this again. For those of you who haven't done this before, we'll discuss again when we do metallic bond in your bonding later. So now what happened here is that what holds them together is actually the metallic bond. The metallic bond is attraction between the positive metal ion and the delocalized electron. So this attraction is the metallic bond. Get it? Now, so what, because the delocalized electron is charged, the nucleus is positively charged, so the attraction is what constitutes metallic bond. Okay. Now compare lithium with potassium, rubidium, cesium, francium. As you go down, you notice number of orbitals increases. So as number of orbitals increases, what happens? Size of the atom increases. So this is a positively charged nucleus, and this is the electron. You see how far the electron is from the nucleus, right? And some more, these extra orbitals will provide what you call the shielding effect. So the strength of the metallic bond now is not as strong. Get it? So as you go down the group, strength of the metallic bond increase or decrease? Increase or decrease?
Decrease.
Decrease. Right. Okay. So why? So because the strength of metallic bond decreases, so therefore melting point and boiling point decreases. Right. Get it? So just now I asked you now, why is it that melting point, boiling point decreases? It's because the strength of the metallic bond decreases. You clear? Now, why the strength of metallic bond decreases? Because of the shielding effect as you go down. Understand? Yes?
Yes.
Right. And then in terms of strength as well, some lesser. Meaning that, remember, group 1 is soft metal. They are soft metal. They are alkali metal, meaning that they dissolve in water to give you alkali, and they are soft metal. Kalau you go to the lab, your teacher can just use a tweezer and then just twist it off, right? So it's a soft metal, but as you go down, it's getting softer and softer. Understand? Yes? No? Faham tak?
Yes.
Okay, now once you understand that, now go to your chemical properties, right? So here you have, right? Now 281, 2881, right? So now how does it achieve octet stability? From lithium, sodium, potassium, rubidium, cesium, and francium. As you go down, okay, all group 1 element will do what to achieve octet stability? I mean,
Lose one electron.
lose
Lose
one,
one electron
right? As
to
you go
achieve
down, does
positive
it get
charge.
easier? Is it easier or not for them to lose electron?
Easier.
Easier because of the shielding effect again, the number of orbitals, right? Sekejap, I tutup pintu. Okay, so as you go down, you notice that number of orbitals increases. This will give you a shielding effect, meaning that it's easier for the electron to be released because it's getting further and further away from the nucleus. Remember, the nucleus is positively charged. As the number of orbitals increases, there'll be shielding effect. So it's easier for the electron to be released. Right. So as you go down, it's easier to lose electron, meaning that electropositivity increases, reactivity. Remember, what is reactivity? It's about tendency of metal to lose electron, kan? When we talk about metal reactivity. Do you remember, everyone?
Yep.
So reactivity is about tendency of an element to lose electron. As you go down the group, it's getting easier to lose electrons. So reactivity increases or decreases?
Decrease.
Increases, right?
Increase.
So
Increases.
increases down the group, right? So the most reactive will be francium.
Calcium.
Right. So if you do this in school, you notice that all group 1 element react violently with oxygen, right? It combines with oxygen to form oxide. What color is the oxide again? From this morning, what color is the oxide? If I give you sodium oxide, potassium oxide, rubidium oxide, cesium oxide, francium oxide, what is the appearance? Describe
White.
the white upper, I mean.
White solid.
White solid. Is it powder or crystal?
Powder.
Powder.
It's white
Powder,
powder. Right, it's white powder.
white
Now,
powder.
is it a base or is it an alkali? Sorry,
It's a base.
base or is it an acid?
Oh, base.
Why is it a base?
Base,
It's a metal oxide.
It's a metal oxide, right?
July.
Base as well as it's an alkali because group 1 oxide is soluble in water.
Soluble in
Remember,
water.
oxide, hydroxide, carbonate, all are insoluble except group 1, potassium, sodium, and ammonium. Right, okay. Now, so next, it reacts violently with water to give you hydroxide, hydrogen. Right, okay, hydroxide and hydrogen. So you can see rapid effervescence, right? And this is an alkali. Why I said alkali again? Why do I use the word alkali?
It's soluble in water.
Soluble, because it's soluble in water. Good. Okay. Now, so now why do you have to keep group 1? Kalau you go to the lab, you notice that your teacher will keep it in paraffin oil. Why do you keep group 1 metal in paraffin oil?
It's highly reactive.
Reactive, so you have to keep it in paraffin oil because
Uh,
to prevent it from reacting with
right.
what? What's in the
Oxygen and
Us
water.
is
oxygen and water vapor?
water vapor.
Keep group 1 in paraffin oil because you don't want it to react with oxygen and water vapor in the air, right?
Okay.
Now it reacts violently with chlorine to form chloride, right? Okay. Now, so you okay with group 1? Yes, no?
Yes.
Right. Okay. So next one will be your group 1 and groups. Next one is group 7. Okay, when you talk about group 7, we have what? Fluorine, but very rare we talk about ester. Right. Fluorine is 2,7. 2,8,7. 2,8,8,7. 7. Right, you get that? So now as you go down, what happened to melting point and boiling point?
Increases.
Increases. Why does it increase? Remember what
The
element exists as
Gain electron.
diatomic.
Diatomic.
Diatomic, right? Fluorine is F2, chlorine is Cl2, bromine is Br2, iodine is I2, astatine. Right, they are diatomic. What does it mean? They are diatomic. Di means two. They're made up of 2 atoms, right? So sharing of 1 electrons. So now as you go down the group, what happened to melting point and boiling point? Increase or decrease?
increases.
Increases. Why is it increases?
The
Atika, why
inter
did it increase? You remember?
Because the van der Waals forces increases.
Yes, as you go down, what happened? This is like fluorine, right? So this is what you call van der
Forces.
Waals forces. Van der Waals forces is the intermolecular forces. And van der Waals forces increases with increasing size of the molecule. As you go down, you notice number of orbitals increases. So now the size of the molecule increases. So therefore, as you go down, the strength of van der Waals forces increases, right? Or strength of intermolecular forces increases. So therefore, increasing melting point and boiling point. Right? Okay. So if you see fluorine, fluorine is colorless gas. What is chlorine, Atika?
Pale yellow gas.
Good. Pale yellow
Right.
gas. What is bromine, Atika?
Brown liquid.
Brown liquid. And what is iodine?
Purple solid.
Purple solid. And astatine?
Black solid.
Black solid. So here you notice that it changes from gas to liquid to solid, right? So therefore you know that increasing melting point and boiling point. And then you see the color from colorless to pale yellow to brown to purple to black. So meaning color intensity also increases as you go down. Reason is because of the increasing strength of the van der Waals forces with the increased number of orbitals. You okay with that? Yes or no? Understand? Right? Now, your chemical properties. All these have what? How many valence electron? Group 7? How many
one.
electron? 1,
7. Sorry.
7. They have 7 valence electron. Right. So to achieve octet, what happened? To achieve octet?
They gain 1 electron.
Yes, they gain 1 electron. Right. Like Cl plus electron to give you Cl minus. Right. You get that? Betul tak? So now as you go down, you have fluorine, chlorine, bromine, iodine. Right. So here, now, so is it easier or not for them to gain electron as they go down? As number of orbitals increases, shielding effect increases, will it be easier or not for the atom to gain electron? Easier or not easy? Someone?
Harder.
Easier.
Yes.
Harder.
Harder because of the shielding effect, it gets harder for them to gain electron. Get it? It's harder for them to gain electron. Therefore, in terms of reactivity, so reactivity decreases down the group. The most reactive will be fluorine. The least reactive will be
I do.
You get that? Reason because their tendency to gain electron decreases down the group. Like group 1 just now, the tendency to lose electron increases down the group. So reactivity increases down the group. The most reactive is francium, right? But here the most reactive is fluorine. Understand? Faham? You get it? Now, reactivity, it react with what? It is a strong oxidizing agent. If you recall back your redox, they easily gain electrons. So they undergo reduction themselves is an
Oxidant.
oxidant. So remember, group 7 is a strong oxidizing agent. Of the group 7, which one is the strongest oxidizing agent? Fluorine, because it's the easiest to gain electron. Group 1 loses electron. So group 1 undergo oxidation or reduction?
Reduction.
Reduction. Are you sure? Sodium to sodium ion. Oil rig. Sodium
Oxidation.
Sodium
Oxidation.
undergo oxidation. Group 1 undergo oxidation. Itself is a
Reductant.
reductant. Which
Reductant.
one is the most reducing of all group 1?
Francium.
Francium is the most. The strongest reducing agent is francium. The most oxidizing agent is
Fluorine.
fluorine. You understand that? Because
Yes.
those of you who have done redox, try to play it in your mind so that you can see the big picture. Now, so it reacts with sodium just now to form right, okay, and then it reacts with iron. Remember, iron have two oxidation state, +2 and +3. Remember, halogen is a strong oxidizing agent, so it will oxidize it to 3. So you're going to have FeX3. Like if I give you chlorine plus iron, I'm going to get FeCl3, right? Okay, it will oxidize to the maximum because it's a strong oxidizing agent. It also dissolves in water, but as you go down, the solubility in water decreases down the group, but that one will be later. Okay. Now, you okay with this? Yes? No? Faham tak?
Yes.
Yes.
Okay. And as far as group 8 is concerned, you just have to know the usage of it. And then transition, we discussed about transition already. Okay. Now, okay, any questions so far? Those of you who have done this before, do you recall back everything? Yes? No? Faham tak?
Yes.
Okay, now, we have done your group 1, we have done your group 7, we have done period 3, we discussed about transition, and then let's do some question then.